This site, in the grounds of a former hospital, is being developed by Bovis Homes, one of the UK's leading house builders. Some of the hospital buildings are being converted into flats, others are being demolished to make way for the new housing. Most of the development comprises houses and flats for sale. In line with current government policy, there will also be houses available for rent. These will be owned and managed by Knightstone Housing Association. Even though the old hospital buildings were demolished and the land cleared by a specialist contractor, extensive site investigation was still required to assess potential problems in the ground, mostly caused by old foundations and basements. On those parts of the site where there were no former buildings, mostly the hospital gardens, strip foundations were used. In the UK, strip foundations are by far the most common type of foundation. It's basically a strip or ribbon of in-situ concrete running under all the load-bearing walls. These will normally include the external walls, the party walls, in other words the shared walls between dwellings, and possibly some or all of the internal walls. Nowadays, trenches are nearly always excavated by machine. The surplus excavated material can be used for landscaping or can be carted away to landfill sites, usually former quarries. Carting material off-site can be very expensive, especially in towns and cities. On industrial brownfield sites, there's also the potential hazard of contaminated ground. Whether it's carted away or left in place, contaminated ground can be an expensive problem. The depth and width of the strip depends on the building load and the nature of the ground. In many cases, strip foundations don't need specialist design. The width can be determined by referring to a table in the building regulations. The ground here is mostly firm clay. This generally provides a good foundation as long as the trench is deep enough to be clear of any seasonal changes. Clays swell and shrink depending on their water content. At shallow levels, this can cause potential foundation problems. The concrete for the foundations is ready mixed. This ensures good quality control. Concrete in its simplest form is a mix of cement, sand, stone and water. Its properties and strength can be altered by varying the proportions of these ingredients. The building regulations require foundations to be at least 150 mm thick, although in practice they're often much thicker than this. In fact, on some sites, the trenches are virtually filled with concrete. This produces substantial savings in block work. The concrete is tamped to give a level, even surface for the bricklayers. Tamping also helps to consolidate the concrete by bringing surplus air and water to the surface. This foundation contains steps. It's still a strip foundation. The steps are used on sloping ground and help keep excavation to a minimum. In some situations, strip foundations are not suitable or may not be the most cost-effective option. If the ground is very wet, if there are trees nearby, or where a good bearing stratum is quite deep, piled foundations may be more practical. On part of this site, piles were used to transfer the loads below old foundations and basements. Below ground level, there's little point in using brickwork. Blocks are cheaper and quicker to lay. A standard block is 2 bricks long and 3 bricks high. They are available in a range of widths and strengths to suit most types of wall. Blocks are made from dense or lightweight concrete. Both can be used below ground, but dense blocks are normally cheaper. Laying the blocks can commence as soon as the foundation concrete has set, normally a few days after pouring. Depending on the preferences of the designer, the walls below ground level can either be solid or cavity construction. While building the walls, the bricklayers must form openings for water and drainage pipes. Concrete lintels support the blockwork over the opening. Water pipes should be at least 750 mm below finished ground level to avoid freezing, and drainage pipes should be deep enough to avoid physical damage from traffic and over-enthusiastic gardeners. The correct positioning of these pipes is critical. Mistakes can be very expensive to rectify once the ground floor is laid. A modern house will also be connected to a number of other services. Electricity, gas, cable TV and telephone all have to be connected, but won't necessarily run under the floor. A damp-proof course, DPC, separates the substructure from the superstructure. Nowadays, these are usually made from flexible materials such as polythene. As its name implies, the damp-proof course acts as a barrier to ground moisture. The ground floor is a suspended concrete floor. It's a series of precast concrete beams with an infill of polystyrene blocks supporting a poured concrete topping. The beams are factory-made and are reinforced with steel rods. They're man-handled or craned into place and sit on the DPC. The beams are supported by the external and party walls and are not in contact with the ground beneath. The polystyrene infill blocks are easy to handle and install. They also provide very good thermal insulation. The concrete topping is levelled and tamped and then finished with a power float, smooth enough for tiling or carpets. Most modern ground floors are built with suspended concrete beams. An alternative form of construction, in common use since the 1940s, is a ground-bearing slab. Typical construction would be a compacted hardcore base, usually crushed stone or other suitable material, a polythene damp-proof membrane, insulation, a poured concrete slab, and a thin sand and cement floor finish called a screed. In modern housing, the walls are normally formed in cavity construction, in other words, two separate leaves. If built correctly, the cavity prevents water crossing from the outer to the inner leaf. Modern cavities are usually 75 to 100 mm wide. On this wall, the outer leaf is brick and the inner one is lightweight block. Dense blocks were common in the past, but they cannot achieve the high levels of thermal efficiency required by current building regulations. Even lightweight blocks, unless they're very thick, will usually require additional insulation. These insulation boards are made from foil-faced rigid urethane which partially fill the cavity. The foil facings improve the thermal resistance of the cavity. Insulation can also be in the form of insulation bats which fill the cavity, or an insulated dry lining on the inner face of the blocks. Wall ties bind the two leaves of the wall together. These days they're mostly made from stainless steel. Their frequency is determined by the building regulations. The red plastic washer on the tie holds the insulation boards in place. The kink in the centre of the tie forms a drip and stops water reaching the inner leaf. The bricks and blocks are bedded in mortar, usually a mixture of cement and sand with various additives to improve its workability and durability. A good mortar will have adequate compressive strength, ensure the wall acts as a single structural unit, resist frost and chemical attack, keep out wind and rain. Mortar can also have a significant effect on the appearance of the building. In recent years, the use of pre-mixed mortars has become common. These are delivered to site in sealed containers ready for use. The upper floors in the houses are constructed from metal web joists. These are light enough to be lifted by hand and can often span the width of a modest house without intermediate support. They're spaced at 600 mm centres and are supported either end by metal joist hangers which hook over the blockwork walls. Most houses are still built with solid timber joists. These have the advantage of being more readily available but cannot span as far, so in most cases an internal load-bearing wall is required. These walls usually require foundations. The joists are covered in tongued and grooved moisture-resistant chipboard, 22 mm thick. The chipboard is nailed and glued to the joists. Gluing the boards down and gluing the board joints help prevent squeaking and creaking. Openings have to be formed in the cavity wall for windows and doors. There are two important issues when forming the opening: preventing damp from reaching the inner leaf and safely carrying the loads of the wall above. Here, the designer has chosen to use insulated plastic extrusions which fill the cavity and provide a good fixing for the window. The windows will be fixed later to prevent them getting damaged. Galvanised steel lintels support the loads over the opening. The lintel is shaped so that any water running down the cavity is ejected through weep holes. Modern lintels can also be stainless steel. In the past they were made from concrete, timber and even wrought iron. Most modern roofs are constructed from prefabricated frames called trussed rafters. These are quick and easy to build and will span from wall to wall without any intermediate support. Individual trusses can be lifted into place by hand or by crane. Trusses can be designed to suit almost any roof shape. These particular ones have been delivered to site in two parts because of their size. Once in position, additional timbers called braces are added to make the structure rigid. On some sites, the entire roof structure is assembled on the ground and lifted into place by crane. Trusses have been common for more than 40 years. Before this, carpenters built the roofs on site from individual sawn timbers. These are known as cut roofs and can still in fact be found today, mostly on one-off housing developments. Before the roof coverings can be fixed, the top of the cavity must be closed to protect against the spread of fire. Here they're using a mineral quilt wrapped in polythene. If a fire starts on a lower floor and gets into the cavity, this barrier should stop it spreading into the roof, at least long enough for people to escape. At the feet of the rafters, a fascia board provides a fixing for the gutter and supports the bottom course of tiles. Most houses have overhanging eaves and therefore a soffit board is required to hide the timbers. A good overhang at the eaves will keep rainwater well clear of the brickwork. Long-term saturation is the cause of many defects. To prevent high heat loss, the roof has to be insulated. Normal practice is to insulate at ceiling level using a fiberglass quilt. Because the roof space above the insulation is cold, there's a risk of condensation. This can be confused with rain penetration. To remove the moist air, a roof space is normally ventilated, usually from eaves to eaves. On this site, there are rooms in the roof, and the insulation, in board form, has been fixed between the rafters. This makes ventilation a bit more difficult. Most modern roofs are covered in concrete tiles or imitation slates. Underfelt prevents wind-blown snow and dust from getting into the roof space and directs any water getting through the tiles down to the eaves. This underfelt is a vapour-permeable synthetic material. It allows vapour to escape from the roof space, so a roof with a simple rectangular plan does not always require ventilation. Ventilation, if the designer prefers it, can be provided by eaves-to-ridge vents. A mineral wool quilt laid on top of the party wall helps to prevent fire spreading from dwelling to dwelling. The underfelt is secured by the tiling battens which are nailed to the roof trusses. The tiling battens support the roof covering, in this case artificial fibre cement slates. Natural slates are still available but are very expensive. Once the house is weatherproof, the pipes and cables for the heating, plumbing and electrical services can be installed. Work which takes place before the plastering and is concealed in the walls and above the ceilings is known as first fix. Although copper pipework is still common for heating and plumbing, plastic has become a popular alternative. It's easy to cut and join, light to handle and fairly flexible. The smaller diameter pipes, usually feeds to individual radiators, are available coiled. This reduces the number of joints and the thin pliable pipe can easily be fed around obstacles. The pipes are joined by push-fit connectors. A quick twist locks the pipe in place. The fittings don't require any glue, solder or heat. They are, however, a bit more expensive than traditional copper fittings. Some plastic pipes cannot be directly connected to boilers, hence the short lengths of copper. Copper tails are also common where the pipework is visible. Copper is also used within a house to carry gas. Party walls have to provide good resistance to airborne sound. Here, the party wall construction comprises a cavity wall with both leaves in dense rather than lightweight blocks. In addition, unlike the external walls, the party walls will be rendered with a coat of sand and cement to further improve sound insulation. This will be finished with a layer of plasterboard, but not until the first fix is complete. Before the electrical work can start, the partitions have to be erected. They're non-load-bearing and built from lightweight steel sections and channels screwed to the floor, walls and ceiling. In the past, non-load-bearing partitions were usually made from a timber framework or special proprietary plasterboard systems. Building a staircase from scratch on site is not really practical. They're usually prefabricated in a factory or joiner's shop and delivered to site in several parts. The staircase basically includes an inner and an outer string and a series of treads and risers. The building regs control the pitch, step depth and height and the dimensions of handrails to ensure safety and familiarity. The electricity supply is metered for payment purposes and then distributed around the house from the consumer unit. There are a series of separate circuits distributing power to the sockets, the lights, electric cooker, hot water cylinder and so on. Modern installations have a number of safety features such as earthing and circuit breakers to prevent electrocution. Electrical installations were not common in new houses until the 1920s. Electricity was first used for lighting. Nowadays it's used for so many things that life without it would be hard to imagine. When the wiring and other first fix trades are complete, the plasterboard can be fixed. 40 years ago, wet plaster was the most common finish to brick and block walls, although plasterboard has been used for ceilings since the 1940s. Wet plaster is still an option today, but many developers prefer plasterboard, usually referred to as dry lining, because it's quick to fix and drying out time is minimal. Wet plaster introduces massive amounts of water into a building. This can take weeks to dry and delays decorations. The boards are usually bonded to special adhesive dabs. The plasterboard is fixed to the lightweight partitions with self-tapping screws. Once the boards are in position, the joints are taped and filled to give a seamless, smooth surface ready for painting or papering. Taping can be done by hand or machine. The house is just about finished and is almost ready for occupation. This film has given a brief insight into modern house construction. Over the last 100 years, there have been many changes in the way houses are built, but most of these have been evolutionary rather than revolutionary. Walls, for example, have steadily evolved from solid to cavity. Roofs have evolved from timber cut on site to prefabricated trussed rafters. From the occupier's point of view, these evolutionary changes are neither here nor there. They've had little impact on lifestyle and comfort. But there is one item that has had a dramatic effect on all our lives, and that is electricity. It'll be interesting to see what changes occur over the next 100 years.